Hello guys, welcome to tutorial 3 under Thevenin's theorem. So in this tutorial we are going to find the current flowing through the 6 ohms resistor using the Thevenin's theorem. So we will start off by finding our VTH by removing the load from the circuit and finding our VTH. So we have the source to be the voltage source. We have our resistor here, another resistor here. So we've removed our load. This is a bridge network. Okay, this is a bridge network. So we have 10 volts, 12 ohms, 18 ohms, 18 ohms, and what? 12 ohms. Good. So we want to find VTH. That's the voltage, the Thevenin's equivalent what? Voltage. So finding VTH, we know we have to consider a loop. Alright, a loop where the VTH is part of. So in this diagram, we can see that the VTH is making part of this loop, and also the VTH is in what? This loop. So we can choose either of the loops and analyze our what? Loop. So let's say we are choosing this first loop. So if we are choosing this first loop, then it means that I will need the voltage across this 12 ohms and the voltage across what? The 18 ohms. Because the voltages for these two will help me get my VTH value. So I'm going to use this diagram to calculate the voltage across the 12 and the voltage across what? The 18. So let's say the voltage across the 12, I'm naming it V1. The voltage across the 18, let's call it what? V2. So now let's see what is happening. There is a current being produced from the source. When the current gets to this junction, there are two branches, so current has to split. So some of the current will pass here, others will pass here. So current flowing through this branch, it flows through the 12. When it gets to a junction, don't forget this part is open circuited, so the current won't split when it gets here. It's rather continue and pass towards the 18. Current through this 18 will also flow here, gets to this junction, then continue its way through the 12 because this branch is open circuited. So we can see that this 12 and this 18 are connected in series, whilst this 18 and this 12 are also connected in what? Series. So we have a series connection here, another series connection here, but the two elements here are connected in parallel. So 12 and 18 in series, let's call it RA, which is 12 plus 18, is giving us what? 30 ohms. So this 12 and 18 is giving us 30. We have another resistance here. This 18 and this 12 in series is also giving us what? 30. So 18 plus 12 is also giving us what? 30. Alright, so we have 30 here, which is in parallel with what? Another 30 here. So we know that elements in parallel also have the same voltage. So the voltage across the 30 here is what? 10. The voltage across the 30 here is also what? 10. So we know that the 30 here is from 12 and 18 in series. So I'm going to use the voltage divider rule to get the voltage V1. That's the voltage for the 12. Don't forget the 12 and the 18 are sharing the voltage here, which is 10. So V1, that's the voltage for what? The 12 ohms is going to be 12 over 12 plus 18 times 10. Okay, that's the voltage across what? The 12 ohms resistor, this one. So 12 over 12 plus 18 times the voltage here, which is 10. So what do we have? We have 120 over 30, and this is giving us what? 4 volts. So the voltage across the 12 is what? 4 volts. Now we are interested in also calculating for V2. So we know that V2, voltage across this 18, is also giving us 18 over 18 plus 12. 18 plus 12 times what? The voltage across this, which is also 10. So I have 180 over 30. So here we have what? 6 volts. So the voltage across this 18 ohms is what? 6 volts. Now we are left to calculate for what? VTH. So don't forget, VTH is what? A voltage. It will have a polarity. Sometimes if you want to know whether the VTH will have its plus or minus here, you can check the question. They are saying the current, you are asked to calculate, the current is moving this way. So you can see that the plus of the VTH will be here, the minus will be there. Alright, so assume that VTH, there is a resistor, so the current is moving here, so plus, minus. So that can help you to also assign what? The polarities to the VTH. So let's get the polarities on this V1 and V2. Their current is coming down like this, plus, minus, plus, minus. So what will be VTH? Let's try it and see. So let's start from the VTH. We will enter negative and leave positive. So positive. We will enter negative, leave positive, plus V1. We will enter positive, leave negative, minus V2 is equal to 0. So my VTH is equal to what? My V2 minus my V1. So for us to get VTH, I have to subtract the voltage here from the voltage there. And that one is giving us what? 6 minus 4, giving us 2 volts. So our VTH in this diagram is 2 volts. The next thing to do is to calculate what? RTH. At the same portion where we did what? The VTH. So calculating RTH, we have to turn off the source as we've been doing. So I'll deactivate this one and my circuit looks like this. I have here, so I have this portion here. Alright, good. So this is where I have my 12, my 18, my RTH, my 18 and what? My 12. So we are asked to find the total resistance in this diagram. That is the what? RTH. So let's see how we can get RTH for this. Let's assume there is a current moving on the branch of the RT. So let's say there is a current moving here. If I take this part, I'll see that when this current is coming, it gets to this junction. What will the current do? The current will what? Split. So current, some will pass here, some will pass here. Meaning the resistor here and the resistor there are connected in parallel. When I check this end of the resistor RTH, when I check this end and see current is coming, I've also realized that there is a current splitting between this branch and that branch. What does it mean? These two are also in what? Parallel. But for this diagram, for what you have to know is that the 18 and the 12 here connected in parallel. This 12 and this 18 here are also connected in what? Parallel. And the resultant of these two here, the equivalent of the resistors here, will now be connected in series. These two in parallel. These two in parallel, and the two here, the equivalent here will be in what? Series. So if we want to find our RTA, let's say we are continuing from here because of space. Let's continue from here. So let's say the equivalent here, I'm calling it RA. The equivalent for this one, I'm calling it RA. So I'll say RA is 12 and 18 in what? Parallel. So I have 12 by 18. 12 plus 18, and what am I getting? So we have 12 by what? 18 over 12 plus 18, and that is giving us 7.2 ohms. 7.2 ohms is the equivalent here. Now, let's find the equivalent for this portion. So that's the 18 and the 12 in parallel. That one is what? RB. So 18 by 12 over 18 plus 12. And that one is also giving us 7.2 ohms. So we've analyzed it that the equivalent here and the equivalent here will end up being in series. So it means my RTH is what? RA plus RB, which is given as 7.2 plus 7.2, and that is what? 14.4 ohms. That is the RTH. So the last thing to do is to what? Draw your Thevenin equivalent circuits and calculate the current from there. I'm not going to draw because I know for now you can draw it yourself. So I'll straightforward calculate the current using the formula. So using the formula, I know that the I, that is I naught, is going to be VTH over what? RTA plus the load. So the VTH is 2. The RTH is giving us 14.4 plus the load resistance, which is 6. And this is giving me, it's giving us 2 over, so we have 2 over 14.4 plus 6, and that one is equal to 0.098 amperes. 0.098 amperes is the current flowing through the 6 ohms resistor using Thevenin's. So I remember in delta Y transformation tool, we used it to solve the current through this and we got the same answer, 0.098 amperes. So this is the end of this tutorial video. Thank you very much for watching.